Welcome everybody. Thank you so much for joining us this morning. I'm really looking forward to an exciting presentation with my colleague Nicole. And so, as you know, Nicole will be speaking about scientific methods in the new K-3 science curriculum. I'm looking forward to learning along with you. I get to moderate this morning. And so as questions come to you, please place them in the chat. And then when there's an appropriate moment, we can share them with Nicole. And if people are putting questions in the chat and you know the answer to them, like the more back chat we have, the better. So feel free just to keep that conversation going. And I think we'll be able to have a really rich time. We have in this presentation, Nicole is sharing ideas about scientific method, and she's got some breakouts in there. And so there should be lots to keep all of us engaged as we move through it. So I'm really looking forward to it. So thank you, Nicole, for giving this presentation, and over to you.
Hi, welcome everybody. So welcome to the introduction to the scientific methods for the new Alberta science curriculum for grades 1 to 3. If you're in kindergarten, just a reminder that there isn't a learning outcome for the scientific methods, but we'll just briefly touch on maybe a suggestion of where you can go. And a little bit about myself, the person you'll be spending the next 90 minutes with. I served as the elementary science consultant with Edmonton Catholic School Division, and I have over 20 years of teaching experience in the elementary setting. And I'm very passionate about science education. So I do a lot of research in the best pedagogical practices or that are evidence-based in science. So I'm going to share some tidbits and things with you today. So as mentioned from Janet, she will be monitoring the chat. I will this session is a bit full, so we're on a bit of a time constraint. So I will pause for questions. Even if you don't put them in the chat or you want to break them down, there will be a moment to kind of maybe open up and ask questions. We are recording for those who are not here or weren't able to attend live. So except for when we go on breakouts, so you can feel free to say what you want to say in your breakouts because those aren't recorded. But when we come back, they will be recorded. And just a reminder, when you do come back, just some etiquette here to mute your mics upon re-entry. And okay, and we'll just begin. So we'll start off with the treaty acknowledgement. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And I kind of want to start off with an agreement between all of us, and that is to position ourselves that nothing is a reflection of your abilities or anything. This is a new curriculum that we are all working through together, and that we're going to have some productive struggle to work through that struggle creatively, collaboratively together, and to take some risks and with some perseverance. Also the situation. So something might not work in your context, think about how it might work in your context. So that creativity piece of problem solving. And we're also here to help if you have questions. So this again is part of your teaching quality standard of collaborating with other teachers to build your personal and collective professional capacity. So yes, there will be breakouts, not a lot, but a little bit for us to process and really kind of understand the science methods at our grade levels. Okay. So the agenda for today is the first 10 minutes. We're going to look or so at science as a discipline to orientate ourselves and provide context to how the curriculum was developed. Then we're going to go through and unpack the scientific methods briefly at each grade level as they relate to the investigation cycle. And then we're going to look at, I think what many of us want is some classroom examples of how would you go about introducing this and teaching this in your classroom. And just a little note, you do get a little digital loot bag at the end. I have a lot of resources or some resources to share out with you at the end of the session. So in that will be the slides, all the presentations, so the slides, and lesson plans to introduce the scientific methods, as well as some assessment look-fors, and we'll kind of talk about that. Again, a reminder that kindergarten doesn't have a learning outcome for the scientific method. But if you look at the computer science learning outcome, which Janet will be doing tomorrow, a wonderful session, you can look at children interpret instructions in various environments, and that can lend itself to following a sequence of instructions for an investigation. So that could be a way of integrating it. And grade 1, it does have the learning outcome, but the investigation is just on a smaller scale, which we'll talk about as well. So some of the key learnings, there's going to be a lot in this session. So thinking about the key learnings that I'd like you to take away today is that science uses methods of investigations to build knowledge and understanding of the natural world. Each grade learning outcome and cusps unwraps a deeper layer or focus on the steps or procedures in the investigation. And understand that students will build on these aspects of investigations at each grade level as they continue on to the next grade. And finally, that there are criteria and there are certain expectations on these skills that are foundational that we can develop and hone in on, especially in primary, to get them ready for upper elementary. All right, so to begin with, let's look at, well, what is science? And how does this sort of the purpose of this discipline? And this is a good reminder. Some of us might be elementary generalists who may or may not have a background in science. And it's just a good reminder just to kind of think about where and why the curriculum is the way it is. So science is the study of the natural world to investigate phenomena. Phenomena are events or situations or facts in an attempt to explain how or why it works or why it's happening. So for example, we have a respiratory virus that is much more serious than the flu. What's causing it? Why is it happening? How does it work? How can we solve it? So those are kinds of things that scientists look at and what science does. So not only is it's a subject that we study in school or an academic pursuit, but it's something that confronts us on a day-to-day basis as citizens. Do we mask or not mask? Should we vaccinate or not? Science seems to be changing its mind. All of these can indicate a lack of understanding of how the process of science works. But also, our students are faced with issues. They're going to be faced with issues like global warming, where they're going to have to make informed decisions. And that is something that we want to develop with our students. So I know that Chris yesterday mentioned that this curriculum in science has changed. It's now thinking about our students on their educational journey with us from kindergarten to grade 12. So you might have them for 1 year, but it's the 1 year that you're building their understanding and skill development in science. So I know we always want to zone in, what's my grade level? What am I supposed to do? And that's absolutely important. But we need to take a step back. And I do remind you of the curriculum subject introduction to take a read of that, because that talks about science as a discipline, but also situates the curriculum. So I pulled out a quote here that says, scientifically literate citizens are equipped to evaluate sources of information encountered in daily life. So as I mentioned, right, it's something that faces us. So we want to develop scientifically literate students. But if we're going to do that, we need to know what it means to be scientifically literate. So PISA, the Program for International Student Assessment, defines scientific literacy as being competent in 3 areas. The first area we're probably familiar with, and it's what Chris touched on in her presentation quite a bit, is conceptual understanding, an understanding of the science ideas in the various disciplines. So we have physical sciences, which is matter and energy, which those organizing ideas fall under. We have earth and space sciences, which is we have earth systems in space. And then we have biological sciences, which is the living systems. So those concepts within those particular organizing ideas is, of course, what we want our students to understand. But broadening out with scientific literacy is also procedural knowledge. And that's the understanding of being able to do the investigations, like to go through the process itself. And Also at the end, finally, what's new in this curriculum is something called epistemic knowledge. And that's just a fancy word. And Janet gave this to me, name and know. So for example, there's sort of lay terms like I have a theory. Many people think that's an idea, which it is. In science, though, understanding that a theory means that there's substantial amount of evidence which is pointing in a certain direction or indicating an idea. What is a hypothesis? How does it differ from a prediction? Those things are what students need to know as well, which is coming out in our curriculum. So as you can see, and I think Carl Sagan kind of encapsulates this, is that science is a way of thinking much more than it is a body of knowledge. So the knowledge piece is coming in our curriculum and the understanding, but the science methods gives it the robustness and the thinking and the process that students go through in order to build knowledge of the world around them. So how does this come back to our classroom in our context? Well, there's been a significant amount of research in science education since 1996, when our last curriculum was in place. And I know in that last curriculum, there was a really heavy focus on hands-on, especially the resources were lots of hands-on and hands-on. And then very little text was available. So, and then in some classrooms, traditionally, is a lot of text heavy. That could be videos or reading. So in the research, the researchers asked, okay, what is the best way to learn science? So they looked at groups that did hands-on investigation only, or learned science through text only, or a combination of hands-on investigation and text. And the classrooms that used both hands-on investigation and text significantly outperformed those who did only straight hands-on investigations or used text only. Okay, because it's about making meaning and understanding the world around you. So traditionally, the sequence of instruction would be, we would give the students a video, or they read about it, or we would tell them, and then they would go off and do the hands-on investigation. But the research is looking at flipping that and making it explore before explain. Because for a couple of reasons, what the research is coming out from developmental psychology and cognitive psychology is that students through play develop an understanding of how the world works, but they may lack the formal language or terms that science has. So for example, a child throws up a ball, they know it's going to come down again. There's certain things they know. And so allowing them the opportunity to explore and then attach the terminology after allows them to sort of have that concrete example of experiencing it and understanding the term. Because if they're introduced to the term first, think of it like a foreign language. You're not going to know what it means unless you have something to attach it to. So there's kind of a couple of reasons for that as well. So we're going to look at unpacking the scientific methods and what they mean now. We're going to switch into that. So I know when we hear scientific methods, we often come up with a traditional scientific method approach, which is fine. But we have to, with a certain linear kind of observe, question, hypothesis, plan, materials, and analyze. There is elements of this, but controlled experiments with the hypothesis are coming in grade 6 actually, but grade 5 starts getting introduced to it. And that in investigation, there's broader than just a controlled experiment. So to touch on that, so for example, Jane Goodall, she's observing her gorillas in the field. Well, she's not able to control her environment. So she's using descriptive investigations to describe her observations. And there's still some objectivity to it. And then we have comparative investigations, which looks at comparing systems over a long period of time, for example, climate, weather, seasons, those kinds of things. And then finally, we have, I'm sure we're all familiar with, is experimental investigations. That one thing that changes and everything else stays the same when you're trying to conduct a fair test. And that, for example, in this picture, it's probably the question is, how do we keep the maggots away from the meat? Okay, we're going to only change the seal, okay? So if you want to think of investigations as an umbrella, and underneath are the different types, and the purpose is still the same. They're still going to have a question that they want answered to find out why or what's causing this. But in an experimental investigation, that involves testing a dependent and independent variable to confirm or refute a hypothesis. So that again comes in grade 5 and 6, especially grade 6 with a hypothesis, and that's the classic scientific method. In an investigation, it does not require a complete scientific method, and a hypothesis is not necessary. So a lot of our students, especially in primary, are not going to be using hypothesis. There's no hierarchy. They're just serve different purposes. They're different investigations that help different disciplines and different reasons. Okay, so sometimes, and I know Chris touched on this yesterday, and I've been asked, how do I go about teaching this? Do I just teach it as a separate unit? Can I infuse this in my, so again, the subject, going to the curriculum introduction for the subject, I pulled out students will have opportunities to integrate these skills in all other areas of the science curriculum. So you would be, this is how knowledge and understanding is built in science. And that's what we want to develop, that scientific literacy. So they should be learning about matter through an investigation and energy and all of the other organizing ideas. Not all the time, but a good percentage of the time, a good chunk. So, and you can introduce it. I know two of the major boards, Edmonton Catholic and Edmonton Public, are starting off with introducing the scientific methods, but then it continues all the way through. So we'll talk about that as well. So now what we're going to do is we're going to unpack the scientific methods at each grade level. And there will be an opportunity to collaborate with, and I'm mixing you up for a very strategic reason, because there's some things that are implied in the scientific methods, and that's something I wanted you to get across to you, and sort of for you to kind of have that processing time to think about where things are on the investigation cycle. Okay, so when Chris talked about the organizing idea, it does go to the end of grade 12. I know that the secondary curriculum isn't quite out yet, but the organizing idea, think of it like planning with the end in mind. So this is what we want. This is the overarching goal, in that by the end of grade 12, they're going to walk away knowing and understanding that investigation of the physical world is enhanced through the use of scientific methods that attempt to remove human biases and increase objectivity. Okay, so that's about the extent of it, and it's kind of broad, but then we go down, and I'm not going to go into the architecture too much because Chris did that really well yesterday, but in order to do that, we need to break it down. And so then we have our learning outcomes, which are summatively assessed and reported on at the end of the year. You have all year to develop this, and the cusps are what kind of help feed into that, and they break it down. Because if we look at, so again, a reminder for assessment, I know that's a question as well. So the learning outcomes are what students know, understand, and do, all of it. And it's what you will summatively assess and report out on. The cusps are ongoing learning outcome is broken down. So if you want to think of the old curriculum had the general learner expectation, and then underneath was the specific learner, it's like the cusps were combined in this, like the specific learner, but now have been separated into the know and understand is the big idea, and then the skills. Okay, so we are to teach all the cusps, and formatively assess most of the cusps, but not all. And we'll talk about it, but it is a good majority that you will be formatively assessing. It's going to feed into your learning outcome and providing feedback to your students on what they're learning. How are we doing in the chat, Janet?
Yes, we have. We've just had a little bit of side conversations going on in the chat. One of the ideas that's been coming up like lately is people have been wondering whether there's some teachers using the grade 4 to 6 next year, and then other people have been asking about the French immersion resources in the new curriculum, and I have been looking just to find the link to our ARPDC resources. I'm going to paste that link in the chat. I don't know how those links, if they're going to be the same, but all of the resources in French and English for all of
You
the
know what?
subjects will be shared on ARPDC.
Yeah, and let's leave the links to the end of the presentation. So if you could find that, would be great. There is somebody on ARPDC working on translating, so we'll share that out at the end because we're going to go into some analysis right now and some processing. I'd like to leave it to that. And then definitely we'll share that link out with you at the end. We won't forget. Those are all really good questions. It's just that now we're going to kind of head into.
We're going to deep dive now, right?
Yeah, we're deep diving.
Okay, and please keep adding questions in there because then you can kind of leave those questions in that parking lot and we'll come back to them.
Okay, so if you want to think of an analogy for the scientific methods as unpacking layers of processes through the grades. So whether you teach French or English, it's still going to be the same. I know that, some of the ideas and resources we'll share out at the end, but it's a cycle. Or think of the Russian nesting dolls that every year the students are going to build on and unpack certain parts of the curriculum and the investigation cycle. So the investigation cycle, I have turned it into a cycle like this because in the curriculum, it's laid out in grade 2 knowledge and implicitly that carries on through to grade 5. It's expanded on and added to in grade 6 with hypothesis. And grade 5 starts bringing in the controlled variables and the experimental piece. So this is what we're going to be working with today. So going through now grade 1, as a reminder, grade 1 actually is a smaller scale of this. I didn't put it, I kind of will show in a bit what grade 1 looks like, but there's aspects of this. Okay, so to begin with, and we should all know where our previous grade is coming from because those are skills that implicitly are going to come through. So students engage in and describe are the verbs. In what are they describing? The concept investigation. Okay, so they're expected that they're going to engage in that. That's what you're going to summatively assess and how they describe an investigation. So let's look at the cusp. I think of the understanding statements as the why. Why are we doing this? And so if you look at the question, ask questions sparked by curiosity, it's going to connect to the students need to know that, but it gives you as a teacher the parameters of what the expectation is in grade 1. So for example, predict an answer to a question. As a consultant, I've heard, and even I myself 20 years ago would say, well, prediction's a smart guess. But what does that mean to a student that you're smart and you guess well? But a prediction is much more than that. It's a little bit more nuanced. It's actually a likely answer to a question. So that has to be relating to the question. And it's based on your current understanding. So there's some background knowledge that's being used to make an inference or to anticipate what they're going to observe. Describe the steps of the investigation. We saw that in your learning outcome. Well, what steps? Well, here are the focus for the grade 1, asking questions, making predictions, gathering data, and forming conclusions. And what's a conclusion? It's an answer to a question. So if we go back quickly, demonstrate safety and respect for an investigation. That's an example where I would teach that and maybe do a checklist, but I'm not going to overly stress on that for a formative assessment. That would be an example of what maybe you may not need to, assess. Okay, so now the second cusp in grade 1 is the big understanding or the why behind we're doing this is recording data helps ensure observations can be referenced in the future. So why do we get students to draw their pictures or do it? Well, it's actually because they should be looking back at those pictures and those observations they're writing down to make a conclusion. So let's go and unpack this a little bit. So making observations uses, so they need to know that, okay, that it uses the senses, record observations as data. Well, how would I get my students to record it? What ways? Well, our curriculum lays it out for us in grade 1. Now it says such as, so it means I don't have to do words, drawings, pictures. I don't have to do all of them, but it means you want to kind of expose them to a variety of ways other than just drawing to record their observations. So they can do number counts. That's great for integrating math, videos, recordings. And then they're going to reflect on those recordings to make a conclusion at the end. And that's what scientists, like, why? That's what we do. That's what scientists do in order to kind of go back to and think about, because it's, again, scientific methods is a thinking process. Okay, so now we're going to have a little bit of processing time. Okay, so what we're going to do is I want to make sure that you understand the task before we go out into a breakout room. If you're on your phone, you'll probably be in a breakout room and you may have not be able to access the Jamboard, but that's okay. Someone in your breakout room can share it with you. So what we're going to do is you're going to think about the skills and procedures, okay, just for grade 1, which is the yellow. And your breakout room number is going to be put on the top here of the Jamboard where it says breakout room number 1, okay? And I have the investigation cycle with all the steps: asking questions, making predictions, planning investigation, observing and recording observations, analyzing data, reaching conclusions, discussing and observing observations and conclusions. So what you're going to do is you're just focusing on grade 1 only. And you're going to look at the skills and you're going to go, okay, for example, ask a question sparked by curiosity. Well, where would I place that on the investigation cycle? Well, I think asking questions. Grade 1 is very straightforward. Where it gets a little bit different is going to be grade 2 and 3, but we want you just kind of getting familiar with using the Jamboard and being in a breakout room. Again, this gives you an opportunity to see what is implicit in the curriculum. And especially in grade 2 and 3, you're going to see that and what's being carried forward. So we kind of need to know where the students are starting, right? The foundational piece. So in a moment, you're going to get the PDF that looks like this. And what's going to happen is you're going to be put into breakout rooms and a number is going to show up. If by chance you miss the number and you're just in a room, on the top left corner down here, you can see room 1 right here. And then if you're in rooms 1 to 10, you're going to be in that breakout room link, because Jamboard only works for 50 participants. So if you open the tab, if you have more than one tab open, just make sure you only have one tab. And rooms 11 to 20 have their own breakout room. And then rooms 21 to 30 are have the third breakout room. Okay, so there's going to be about 27 breakout rooms. So you each have a link, and as you can see, the Jamboard tells you on the top when you open it what breakout rooms. You might have to kind of tab over. Are there any questions, Janet, before we do this about it?
No questions. We do have, of course, some people who are on phones. And so I've just made the comment, like, if people can share their audio, others will understand that they're on a phone. And so that's different.
Yeah.
Worst case scenario, if none of your audio is working, then you'll just be like in the breakout room, like watching the other conversation. Nicole and I will be hopping back and forth through the breakout rooms in case, you know, sometimes it ends up being a room with just one person in it. So we might move, you might find you get moved around to a room that's a little bit more active.
Okay.
And shall I paste the link now?
Yeah. So just don't open the Jamboard links at all until you know what room you're in, right? Because it's very specific to what room you're in to get to the Jamboard links. Okay. And if you open the wrong one, just go back and you can get into the right one. Okay. So Janet, if you could go ahead and drop it in the chat.
Just dropped it.
Okay.
So please, if there's any trouble getting to that like PDF preview page, just let us know.
All right. And always know that that's why we're starting with grade 1, which is a sort of simpler version, so that you can just orientate yourselves, introduce yourselves to each other and use it. And we'll be monitoring on the sides as well. And then we'll bring you back in about 5 to 8 minutes. We'll see how it goes. Okay. Okay, people are start coming back.
Nothing happened in our breakout room.
Did the link not work?
Nope, I just got black screen and the participants.
And Janine, were you with anybody else or just by yourself?
Oh no, there were 4 or 5 other, 5 others in there.
But they couldn't access the Jamboard?
No,
Like it's demonstrates safety and respect during investigations. It's kind of one you have to, you expect the kids to be doing that during the whole investigation.
Okay, is everyone back in the room now?
Oh,
Okay, so Janet, you can mute the mics as well. Okay, so do we have any questions? Because I'm sure some people were saying that they only saw a black screen. So this was a trial period for trying out the breakout rooms and seeing how that'll work. But does anybody have any questions? You can use your virtual hand or any comments that you'd like to share. Lori. Oh, hi, Lori. I know Lori.
Hi, Nicole. Nice to see you. Hey,
Nice to see you too.
Question for you regarding, was there supposed to be one yellow square per circle, oval, whatever we want to call those?
Yeah, we'll go over that. You know what?
Okay,
Not a
perfect.
hard yes on that. And there's some room for flexibility of this.
Yeah.
Absolutely. And that was just to getting you thinking about it. Okay. But thanks, Lori, for that question.
Thanks. Great activity.
Okay. So, Janet, any questions in the chat before I move on?
So the chat is, sorry, I was just working on some, there were so many people in the group, waving the stickies around, we ended up nobody doing anything in our group. It sounds like an exercise on electrons. Group 1 was happy it worked well, but I think, yeah, I think people have got in there and done some work with the Jamboards, and in some places it was maybe a little bit more successful than others. Great. There's a lot of collaboration, I think, happening in the groups, helping each other out. Back to you, Nicole. Yeah, it looks like there were some tech issues with black screens showing. So it's good feedback for us too. Yeah, I think it was sort of a tech thing.
I'm muted. Thanks. So I was talking away and I didn't realize I was muted. So asking questions to spark curiosity, that obviously aligns, and predicting the answer based on their understanding. And then gathering data and making a recording of observations, and then reflecting on the data to form conclusions. And then they would describe all of the investigation piece. So it was to get you thinking, because grade 1 is the foundational year for investigation. What is an investigation? Okay, so that was just to kind of get you processing it, getting you thinking about where it goes. And I've just kind of aligned it on a smaller scale. Okay, so now we're going to look at grade 2. So grade 2 is examine investigation and explain how it is influenced by purpose. Okay, so we know the foundation has been laid in grade 1. And so now the students are going to examine it further and then look at the purpose of an investigation. And grade 2, your year is a lot to do with purpose in other organizing ideas as well. It's a bigger idea that comes out. Okay, so we're going to unpack the cusps connected to that in grade 2. So the understanding is investigations involve carrying out procedures for a purpose. That's what the why behind what we want our students to know and understand. So in order to do that, they need to explore various purposes for conducting an investigation. What are those purposes? Well, it's laid out. Same thing with developing questions for a purpose of an investigation. It's laid out here. So if you are, sorry, Janet, I'm not sure if you're on your phone with the screen, but it's kind of adding something. If you're, this is the parameters for grade 2. So you can know, okay, it's answering questions. Maybe there's a question that the students need to answer, or it's satisfying some curiosity or problem solving. So That's kind of the purposes. So we need to know that students know why. What are we trying to find out? That's the big thing in grade 2. Then they're going to describe procedures for an investigation. Well, what are those procedures? Well, the students need to know, and it's listed here. That is what I turned into the steps on the investigation cycle. So as you can see here, these are the procedures that students need to investigate and describe. Okay. The same thing here with, investigations involve comparing data. So determine if observations relate to the purpose of an investigation. So they have to be thinking about, what am I going to observe? That's something they're going to have to think about in terms of a prediction. What am I going to observe and what would make sense to what I'm trying to investigate? Then the collaborate to combine recorded data on a single list or chart. So data collected by people performing the same investigation. So that's something that happens collectively. And then compare observations and data with others. So in order to, when they're comparing, they need to know that it needs to be similar if the investigation is repeated. And that repetition of an investigation includes performing the same procedures in the same way. Okay. Now, I'm not going to do the breakout because it didn't work for some of you, and I think that's going to cause some frustration. So what you can do is I'm going to get you to think about it and about what is going to be carried forward from grade 1. So we've already talked about making predictions, observing and recording the data, and reaching conclusions. So if you want to think about, even if you have your Jamboard up, if those of you who have access to it, determine where would you put the grade 2 skills on the investigation cycle when looking at those skills and procedures, because it was laid out in grade 2 and it carries all the way forward. Okay, so what do you think would be brought forward from grade 1 that they're still going to be expected to do? They may not be assessed on it, but they're still expected to do that skill. I'm going to give you maybe a few seconds. Why don't we just pop it in the chat? Someone can kind of write or comment or two about that in the chat. What do you think might be carried forward from grade 1 for sure? Janet, are you monitoring?
I am. We see observations and we see predictions, asking questions, describe procedures.
Mm-hmm. All right. So I brought forward in green, absolutely making predictions. Okay, we know the foundation was to do that in grade 1, so they're still going to do that in grade 2. And I yes, they're going to ask questions, but now in grade 2, they're honing in and unpacking a deeper skill of, well, the purpose of the investigation. What is the purpose? And that question needs to reflect that. They're going to record their observations to look back on them, and they're going to collaborate on a chart. Okay. And then as well, observations and data should be similar if if the investigation is repeated. Now, I put in 2 places, determine if the observation relates to the purpose of the investigation, because that's the planning phase, right? In order to think, what am I going to observe? I have to be planning that out and think about that and anticipate that, with guidance, obviously in grade 2, but also at the end, I need to reflect back and analyze a bit. Did the observations help me find the answer to my question and what I was trying to find out? Okay, and of course, they're going to reflect on the data to make observations. So absolutely 100%, you guys got it. Okay, so thank you so much. Now we're going to look at grade 3 and unpack grade 3 a little bit more. So students relate investigation to building knowledge. So the foundation is laid in grade 1. Grade 2 starts to look at, well, why are we doing this? What are we trying to find out? And now grade 3 goes to what scientists really do. And the whole purpose behind it is to build knowledge. Okay, so we have one cusp for grade 3, but it's a little bit long. So I pulled up one of the knowledge statements and put it on the side. So they're going to collect data using techniques to improve the accuracy of data. Well, what are the techniques? Okay, and that is laid out. The students need to, in order to collect data using those techniques, they need to know it, but it gives us the parameters of what we're expected to teach. And in this one says techniques include. So they can be improve the accuracy of data to include choosing appropriate tools. So that's something we need to teach and assess, carefully measuring and demonstrating objectivity. Okay, but also this knowledge statement feeds into that particular skill. The accuracy of data refers to the correctness of recorded observations. And we're going to look at what that looks like in the classroom. Objectivity is an attempt to influence. So what does objectivity mean? If that's what students are expected to do, what does that mean? So it's there. Okay. Now, analyzing data is something that's introduced in grade 3, and it's a foundational skill that is challenging for students, and it's something that they'll always have to work on, but it's a precursor, grade 3s, for grade 4, because grade 4 then goes into interpreting and then looking at evidence. And just a side note, I know we see data a lot in our curriculum. Data is just facts, numbers, and measurements. That's all it is. When we analyze and interpret data, that's when it becomes evidence. That's the information that we glean from the data to make it meaningful to us, is when we analyze and interpret it. Okay, so what does that mean in grade 3? What's the expectation for analysis? Well, that's laid out in our knowledge statement. And I want to say that noticing changes is really important, but also noticing patterns, things that repeat. So for example, if they're investigating with magnets and they're sticking it to different things, what keeps repeating? Well, it sticks to metal. Okay, so that's an analysis piece. Discussing and collaborating, because scientists will be like, what do you see in this set of data that I'm not seeing? So the students can collaborate and work together and make connections to their previous knowledge. Compare the trustworthiness of data, which comes from an investigation that is repeatable, but also such as, so that means we don't have to teach them all, but be exposed to a variety of different sources as text, websites, elders and knowledge keepers, etc. Okay. Now, it's a cycle for a reason, because once they analyze the data and information is gleaned and they're making some conclusions, they're going to have questions. So analysis is the data that can spark a new investigation. So that's why I've put it into a cyclical, the steps go in a cyclical manner. But most of all, reflect on how conducting an investigation contributes to knowledge building. So that harkens back to what is science as a discipline. It's to build an understanding of the natural world. So that's what we want our students to do. So I was going to get you to go through and do this again in a breakout, but I don't want to frustrate people with the Jamboard's not working. So I want you to think about now, what is going, we know it's kind of coming through from grade 1, which you've already talked about. What's coming through in grade 2? What is going to be still implied that they still should be able to do? And then what are we going to add to and sort of unpack further in the investigation cycle for grade 3? So I'm going to give you a few minutes. Any brave souls want to pop it in the chat? You guys did awesome before, so I'm sure you'll do it again. Just pop in the chat what you think. What are some skills you think are going to come forward from grade 2? And Janet's going to read them out as they come up.
Okay. So the comments coming out, grade 2, lots of work on the planning, measurement. Steps of the investigation. Asking questions.
Okay.
Oh, awesome. Here they
Awesome.
come. Observing and recording, relating procedures for investigation as they analyze data. Predicting and picture graphs interpretations.
Interpreting is grade 4, but I think I know what you mean. You need to use graphs in order to see the pattern. So absolutely for analysis in grade 3, that's excellent. One more and then we'll move on, if there's any more. Okay, thank you so much for doing
Measuring.
that. Yeah, well, measuring does definitely come into grade 3. So you can see in green is what carries forward from both grade 1 and grade 2. So determining the observations relate to the purpose of the planning part, and they're still going to make observations and record them. But now they're going to focus on, I'm going to just move my little thing here. They're going to focus on collecting data to improve accuracy. Now, accuracy doesn't just mean measurements. It means, and we'll talk about recording some of the things, but measurement is absolutely part of it. And the analysis piece, and I put the knowledge under here just to make it very clear. Now, reflecting on how data is building knowledge and contributes to knowledge building is part of referring back to the recorded data to make a conclusion. Because a conclusion is an answer to the question based on your data, support from your data and evidence. Any questions before we move on? Are there any questions in the chat? You're muted.
Okay, so Taylor's asking, did you say that the green text is what is carried forward from past grades?
It is. They're still expected to be able to make predictions. You're not assessing that. You might want to review this. This is kind of a hint on, okay, I'm beginning with scientific methods in the beginning of the year in September. So what could I sort of review with students, and that using the background knowledge, so having that because statement and the purpose for an investigation, but we're going to talk about that. Actually, we're ready to kind of get into that area. Thank you, Janet.
And then
anything?
just one other quick question, which within the group has been able to answer it, but I just wanted to bounce it off you. So someone had asked 5 minutes ago about if we could just repeat the definition of data. And so the comments being made, one person said, I believe she said data is facts, numbers, and evidence. And somebody said facts, numbers, and measurements.
Yes,
and then
measurements.
somebody else talked about observations, measurements, etc. Once you analyze the data and use it to help answer the question, it becomes evidence.
Yeah, so thanks for asking that question. So yes, data is just numbers, facts, and measurements. That's it. And then when you analyze it to pull out what patterns you see, what changes you see, then once you do that, it becomes information that can support a conclusion. And that's done in grade 3 more so than anything else. And then the information becomes evidence and interpretation becomes evidence. I hope that clarifies for you guys. Good question. I'm glad you asked that again.
And one more question just popped in. Can we get a big poster of the science investigation inquiry cycle?
Yes, I'm going to drop that in. I haven't, but I will. I'll drop that into all the grade level folders that you guys are going to get at the end. It'll happen a little bit later today, but I'll definitely put this in. And I did make for you a glossary. So the data is defined in there and some of the terminologies are clarified in that sheet for you. And the little goodies you get at the end today. Thank you so much for the people who've put things in the chat. I really appreciate that. I wish the Jamboard would work a little easier, but in any event, it still worked out.
But it gives us more time to really connect in the chat. We've had another couple of things drop in, so I'm going to just quickly.
Sure.
So Sharon mentions like there seems to be a lot of necessity regarding going back to other grade levels. So she's noticing that recursiveness.
Awesome. Yeah.
As the grade 3s get kids with, oh yes, she's making the point this year, of course, the grade 3s get the kids with none of the background knowledge specifically taught in this way. And so it seems like a lot to cover. So maybe you can give her some reassurance. And then also there's a question, what is the difference between the science investigative inquiry cycle versus science investigation only?
They're the same. It's yeah, an investigation only. It might, the scale of your, it depends on the scale, right? So students, you can go through an entire unit using a whole entire cycle, or you can do small scale investigations where they have to test things. And you see that in your organizing ideas, students conduct investigations. So then knowing, at your grade level, where on what cycle that they are and what they're doing. Great question.
And then the person who is thinking about those grade 3 students not having had the grade 1 and grade 2, do you comment?
Yeah, I'm going to talk about that. Actually, that's our next, we're just wrapping up, and that's our next thing is classroom examples. So how would you go about introducing it and sort of bridging,
Awesome.
doing a bit of those bridge lessons. So that's a really great, your mind is thinking wonderfully. So that's awesome. So thank you guys. To sum up, grade 1 is the foundation year of what is an investigation. So those major things like what is making a prediction, how to record those observations and making conclusions. Grade 2 then expands on that, as we've uncovered, to look at how it relates to the purpose, both invest questions as well as observations in the planning phase and the analysis phase. Tiny bit of analysis, but analysis really comes out in grade 3. And grade 3 looks at, well, this, yes, we know what an investigation is, but really the purpose behind it is to build an understanding of how the world works. And accuracy of data collection, as well as analyzing it so that it becomes something that we can learn from and use. Okay, so now the questions that are all in our minds is anticipating, what does this look like in our classroom? And what I put down at the bottom is for grades 2 and 3, I'm going to highlight the common foundational skills. Okay, so that you're going to start in September. You've got 4 weeks to kind of introduce the scientific methods. I would begin the first week or so, and I gave you some lessons for that, particular to your grade level. 2 and 3 kind of have similar, and then grade 1 has a separate sort of lesson where it goes off into the senses, because that was a kindergarten expectation as to what are the 5 senses and exploring that. So grade 1s, you probably would like to have your students kind of foundationally build on that and what is the senses and using them to make observations. But all students, just like math, right? We're going to have to review a few things at the beginning of the year, every year, even though they've been taught how to make a prediction or record their observations. They're going to need to have reminders of that at the beginning of the year. So these are sort of foundational things I think would be great to start with. So on that note, some people ask, should I have a notebook or a science journal or a graphic organizer? That's your choice. Science journals are great if you feel comfortable with that, with the half and half, so where they can draw pictures and record. But regardless of whatever you use, I highly, highly recommend having either a student glossary or a science word wall, because science jargon or science terminology, as we are even discovering ourselves in our curriculum, can be an inhibitor to students. And that, as my time as a consultant in elementary science, looking at the PATs, that was some of the facts of the science terms that students didn't understand the language. So being very cognizant of that, and I will talk about that and give examples of how to do that in your classroom as well. Another side note before we kind of look at unpacking prediction and recording observations is that we have to make sure that whatever we purchase, whatever resource we use, aligns with our curriculum. So I have seen things floating out there, like even for grade 3, 4 Alberta curriculum, and I see this template of scientific methods people are using, but it has hypothesis. And again, we're developing that scientific literacy for our students, so we don't want to develop a misconception. A hypothesis is different than a prediction, and so we should look at maybe modifying it or look for something else. Now, what I have developed and will be shared out with you today is an investigation template for each grade level. So you can see here, grade 2 is, what are we trying to find out the purpose? What questions are we investigating? So you can use that or modify it to your liking, or you don't have to use the whole thing. You can use part of it as they're working through different parts of an investigation or as a guide. Okay, I want you to think about assessment as well, because you are teaching and assessing, especially formatively, the cusps, and then summatively assessing the learning outcome. So I want to just remind you that we are, because in grade 1 it says teachers are scientists that do investigation. We gather data, on our students' learning. So we want that data to be valid and reliable. So we don't want to just focus on tests and quizzes. I know that's kind of the traditional or presentations, but I know in primary, we're pretty good at doing observations, right? Just gathering that evidence with the anecdotal notes or checklists and videos, as well as students should be talking in every classroom, regardless of subject. So peer-to-peer conversation, listening to those, or having one-on-one conversations, and the students self-assessing. Okay, so we're going to look at making predictions. And this again for grades, obviously for 2 and 3, this could be a good starting point as well for review. So teach and assess in grade 1, and we can continue with that. So we're going to look at what is a prediction, how do we introduce it to our students, and how do we teach and assess? Okay. So a prediction we know is a likely answer to a question using what we already know. So my colleague Ted Zeroni had developed these concept attainment cards called What is a Prediction? Some of you who've worked with Chris and Ted would have access. I have put these into all of the grade level folders. These would be a great review. So we're going to just walk through 2 or 3 examples, and then you'll know kind of what to do with them. Now, what we're going to do is we're going to look at images and look at the yes statements and the no statements. That should say all the yes statements have in common. Okay, we're going to look at the pictures and think, what do all the yes statements have in common? So in grade 1, the beginning of the year, I would have slides more like this, and these are the kinds of slides. The runner is going to win the race. The no statement, the runner is at the start line. So grade 1s would be seeing a little bit more simpler sentences like this, and they would be thinking, you could stress is going to win, will, okay? Now for grades 2 and 3, when they should know that it's the background knowledge, for example, this could be one, the yes statement. The snowman will melt in the spring because the spring gets warm and snow melts. The no statement, the snowman will walk away because I watched a cartoon and the snowman walked. Not a likely answer, okay? That would be another example. Another one, the girl in the white shirt and red pants will catch the ball because it looks like the ball is falling towards her. No statement, the girl in the light blue shirt will catch the ball because I want her to. Okay, so it's sort of establishing that criteria for the students to think about and start looking at, kinds of predictions and examples of them. So then all of the yes statements are predictions. What is a prediction? So the students could think pair share and have a discussion and share with you. Then you would introduce the authoritative explanation. Okay, that explore before explain. So now let's solidify. They've been thinking, their minds are primed. Now let's give them the real kind of definition. And this could be a vocabulary card that put on your science wall, and or they put it in their glossary, whatever you decide. Okay, so I'm going to pause for a moment. So based on what you've learned about predictions, especially in grade 1, because you are assessing, and just thinking in grade 2 and 3, what are the criteria? What would you want to see or hear from students based on our curriculum for a solid prediction? And some brave souls, can you drop it in the chat? So I put the knowledge statement with the skills and procedures. And what would you want to see or hear from students when they make a prediction by the end of grade 1? And if you're reviewing in grades 2 and 3, and Jana will monitor the chat for that.
And just as we're working on it, Danielle has been just double checking about how things are being translated into French. And I know my interactions for the strand I'm looking after, I know what's going on there, but I'm not so sure about yours. So she's asking about if the specific folders are being translated into French and shared back with them.
Yeah, they are working on that. Yeah, they haven't been done yet, but they are working on that. Any comments about assessment?
Yes. So we have use of the introduced science specific words introduced through the year. Maybe a because statement so they can say why they're giving that prediction.
Yeah.
Prediction needs to relate, there's lots here. A prediction needs to relate directly to what the investigation is looking at and only uses facts, not opinions, to make a judgment. The language they use, is it reasonable or probable, not using opinion to make predictions. Example prediction, I think the water will be solid after it is in the freezer because I make ice cubes at home. Are they using what is already available information in their prediction? They can actually provide examples of a prediction to link back to the concept attainment examples. Sorry, this is jumping around a little bit, lots coming in.
Well, that's awesome.
Yeah,
Thank you.
that they can
Here.
provide a likely or unlikely outcome. Can students use what they know, observed, in order to make a prediction? Assessing this can be challenging as it requires background knowledge of a certain area of study, which goes back to your beginning, but opinion versus prediction. So for the yes/no statements, yes is what we want them to say, and no is what they shouldn't be saying. Did I get that right?
Okay, well, let's go over that. Those are awesome thinking, and I really appreciate you guys dropping that into the chat. So a prediction is a likely answer to something based on your current understanding. So we have to understand that they're at a grade 1 level. So what would they currently have? So I provided an example here. So a likely answer to the question we know. So here's an example of a question posed to students in a living systems. What do you predict will observe grows outside? So of course, now they can draw and they can scribe or write, but the student response can be verbal or pictorial. It should be pictorial in grade 1 as well. But I predict I will see, they could use the word observe, grass, birds, and trees. Now, if they stopped there, that's a likely answer, but it's not completely a full-on prediction, right? I see because so somebody said the because statement. Yes, absolutely. When I go outside, I see grass in the field and trees. Trees get bigger and grass grows and you need to cut it. Okay, but what happens if the student just stops at I will see grass, birds, and trees? So I have a little teacher prompt at the bottom that you can use. What makes you say that, or what makes you think that? Those are, if you ask why, sometimes students will shut down. But what makes you say that is a really nice prompt. It opens it up for them to kind of elaborate more. And there's a template here that you could either use in grade 1 or onwards. Okay. So
we have a couple more questions in the chat, Nicole.
Sure.
And so I'll just sort of, so number one, would we want to see analogies? Maybe we'll just address one at a time.
Okay. It's using your current understanding, which is a bit of your background knowledge. If they're making this is a full year, right? So especially in grade 1, in the review stages of grade 2 and 3, or, kind of reviewing that, I would be kind of really pushing for that, what do you know about, what grows outside? What are some things, kind of probing those questions a little bit more. In analogy in grade 1, I would say, okay, how do you know that? And sort of working with them, we're going to talk about gradual release of responsibility to model that. Analogies may be okay to start with, but you're going to push them towards all year, towards sharing what they know or why they know that. And they do tend to naturally do this, some better than others, but we'll kind of work through that. What I have developed here, and is going to be shared out into the folders, is an assessment. These are kind of look-fors. These are more formative assessment. So for example, this is going to be for grade 1. Students, the criteria, student provides an answer to the question that is appropriate to the context. So it's a likely answer. That's one part, not yet, with some prompting or by themselves. And then I have some prompts here. So they don't have an answer to the question. Think about what you know about something. Okay. When something happens, and then shares on, now the second criteria is the student shares the reason for the answer based on what they already know. Okay. Their current understanding at their grade level. We have to kind of keep that in mind. And a prediction is different than an observation. In grade 2 and 3, they're going to start working on anticipating the observations, but in grade 1, they're just kind of working on sharing what they know and how they know that. So the question is, and you can turn these rubrics into Google Forms if you want to think of tech that way. You can kind of have it and go around with your boards. But relating back to that question again, do we accept analogies? This is where it's a full year process. So I don't think of I do as I write. I think, we think together, you think together, and then you think by yourself. And so this is the gradual release of responsibility. So you can model through a think aloud. I think, I think we're going to see some trees, some birds, and then because you can model the because statement, because I know I've mowed the lawn. So you're modeling that think aloud for students. In the we think together phase, and you can go back and forth, depends on your context, depends on your group. The students could be with you on the carpet or at their desks, and you say to them, what do you think you're going to see outside? And they can think, pair, share, and hand up, stand up, kind of mix it up a bit. And then you're circulating and listening, and then the students share with you. You can maybe share the because to begin with to scaffold, or get them and work together on crafting the because statement. Then when they've done that and you feel like, okay, they seem to be getting this, try it out with they do in partners. You circulate, do you need to bring them back to a we think stage, or do they think together? And eventually it'll lead to independence on their own. Now, this isn't linear. You may go back and forth depending on the context of what they're making predictions about. Okay, so it is a year-long process for grade 1 to move beyond analogies to get them to explain how they know. Okay, and we'll talk about sentence stems, but that might be a really good avenue. Janet, one or two quick questions, because I don't want to go over time. I've got lots to go through.
Yes, there's been some good conversation in the chat just about those sort of after the analogies conversation. So one person asked, I'm going to give you the questions at once. Like,
just
are students developmentally ready to distinguish between opinion and facts? But then as it continued, people talked about the value of the word wall and connections to the ELA outcomes of being able to make sound predictions by giving a reason that makes sense.
Absolutely,
and the
good idea
of the yes/no statements, and it was like, is it what we want them to say versus what they don't want to say? But the response was, well, it's not that one is right or wrong. It's just that noting to students that they're different. And it's that sense of like, because, and which is an opinion and which is prediction, if that makes sense.
Okay, so yeah, an opinion is I feel that the girl I feel like the girl in the shirt, when I talked about that, that's an opinion example, right? Whereas an inference is what you know. So like, for example, with the trees cutting, like cutting grass, right? You kind of know that you've had some experience of seeing that what grows outside, what grows because you've seen trees get bigger, or they've seen that the grass is cut before. So that's something that you know. So it's kind of like, I know, I say this because I know. So you might want to prompt with, because I know. What do you know already about the topic? And kind of working with that. Okay, awesome thinking here, guys.
And a big vote for gradual release of responsibility.
Yeah, I'm a big fan of it as well. Okay, so now we're going to focus on what I think is the foundation to science methods, and that is making observations, and then as well as recording them. So again, we know that we've got our students in grade 2 and 3 at the beginning of the year. We're going to bridge some of these things, and this is a great review, and we're going to talk about that. Some foundations and expectations, because in science, it's not just I'm asking a question. What happens with the scientists is that they notice something first. They make an observation first. Then they go, oh, it sparks their curiosity. So that's why I think it's actually really foundational. And it's where we start looking at getting our data. Now, there's some research in science education on the challenges and misconceptions with recording observations. So we're going to look at those and how to mitigate them. Okay, so what has come out is there is definite competencies or characteristics for children to make good and accurately record observations. So in grade 3, I know we kept thinking measurement, but we're going to talk about the criteria of recording observations. So it needs to be clear. So when recorded, scientists go back and look at and use it as evidence. So that started off in grade 1. right? That's the purpose of recording the observations, is we're going to use them to make conclusions. So grade ones, that would be a skill I would work on. Is it clear? And we'll talk about what that means and looks like in a bit. Is it complete? Does it have all necessary details to describe the situation and event and object well? So grade 2s and 3s, you're going to work on that as well. Accurate. So this is a grade 3 teach and assess area. So think about this. Need to represent what is actually seen, heard, smelled, or touched as closely as possible. And the measurements are accurately recorded. Okay, so we'll talk about examples of that. It needs to be objective, using standard tools to measure exactly. So when they're using those tools in grade 3, not describe an emotion or feeling. Okay, so for example, the seed is 35 millimeters long is objective for recording the data. When they start saying the seed is long, that becomes an inference. And they're attaching, like, it's what they would say is kind of like putting emotion or feeling. That's what they mean by that. It needs to stay with just the facts and numbers. Okay. And it needs to be labeled, and when appropriate, use scientific vocabulary. Okay, so again, we talked about explore before explain. So if you're explaining and the vocabulary is being introduced, they can go back and label their diagrams, or just in time teaching of the vocabulary, then they can go and add that vocabulary to their diagrams. Okay, so we're going to talk about the challenges and misconceptions with recording observations. So students think they will remember their observations and they don't need to write or label them. I think a lot of us have experienced that with agendas as well. And we'll talk about what to do in these situations. Students often record, and this is something we do naturally. We often jump to making inferences rather than an observation. So for example, the grass is brown is an observation. The grass died is an inference. So the student might just write in their recording, the grass died, instead of actually describing. And that leads me to pause for a moment, because there was a question that came up yesterday. Is it good to start with matter or living systems? I'm just going to weigh in on my own opinion, and I'll tell you why. I would start with matter in primary, especially because we live in a three-dimensional world, and matter is anything that takes up space and has mass. That's three-dimensional definition in math as well. And so when they're described, they're given the vocabulary to describe these three-dimensional objects, their properties, their texture, their shapes, all of that. I would start with that, because then you're giving the students the language to be able to go into Earth systems and make observations and describe those systems, or the living systems, the shapes, the things they see, because that's going to connect to certain pieces and concepts that they're learning. Now, it's just my own professional opinion, but it doesn't overly matter, but that's why I would start with matter. Students might not notice important details. And some students sometimes like to attach emotion and draw hearts and things on their observations. What do we do to support this, and how can we kind of overcome some of these challenges? Well, when recording the observations, co-construct criteria. If a student knows the target, no matter what the grade level, they're better able to aim and hit it than if they don't know what the target is. So if we're going to record our observations, these are the criteria that they need to be clear. And what does that mean in student-friendly language? Complete, accurate, etc. Okay, so co-constructing criteria, you are developing, when you do that with your students, not only are they hitting the target, they're better able to peer and self-assess. I always used to have, and you have to model that with your students too, but it's worth the time, the payoff, trust me. When they know how to do that, you know, and they have a simple little checklist that they can go back to before they hand it in to you, that pays off in gold to take the time to do that in September. Use of sentence stems. We have a high percentage of ELL learners in Alberta, and what's good for ELL is probably good for all learners. You know, I listed a bunch here. Choose one sentence stem and a word bank that helps them fill that in and be able to talk about their observations first, or record them in writing. Examples and non-examples. So at the top, you know, with the pictures, does it represent, is it recognizable? That's a question that, you know, where it's not an art class, but is it recognizable? that would be more kind of the lines of questions I would ask the students and labeled. So this is an example of it. I can't tell what that is in this picture. And I know in grade 1, there's just starting to work. So it's a little bit of, okay, how can we kind of make this a little bit more look like what we observed? Okay. Now in grade 3 with accuracy, the boy is writing it down. The boys are accurately, looks like they're being accurately recording, but they're not recording it. Okay, so examples, non-examples are a great way to introduce that and continue that with your students.
There's a question in the chat, just quickly. Chris is asking, do you have a scope and sequence for the topics in this new curriculum? For example, beginning of the year, scientific method, then matter. And I know you talked about matter just now.
Well, that Edmonton Public has put out their scope and sequence. I think Edmonton Catholic did as well. It might be a little bit different, but Edmonton Public does have a scope and sequence, which if you Google it, you can get it for free. But I can't just, I mean, Edmonton Catholic has it as well. I believe that was in Chris's session, which it will be shared out as well. She had a link to all the scope and sequences. I'm running out of time.
Yes, keep going.
Okay, so now another important area, and this takes a long time to work through, especially with grade 1s and 2s and even 3s, is distinguishing between observation and inferencing, getting them to slow down. So many of you might have heard of see, think, wonder, and I've adapted it to see and think. So using words to describe. So that is an observation. They're describing. So it could be color, shape, well, the property without naming it. And so I worked in a grade 1 classroom and I gave you this. This is in your, we're going to share this out. It was like a screen of different images of different objects. And the students had to work on describing the objects in a way so that others would be able to infer what they're describing. So for example, like if I said, I see something that's black and white, as opposed to I see something that has black, white, and fins, right away, then you can infer with the fin that I'm talking about an orca whale, if that was the image, okay? So that goes under the think column, orca whale. You can jot down the C there. Now, to get them to slow down is something called a ×2 looking routine. And that is where students will describe first, look away, look back, and add more descriptions. Okay, so those are some things that you could do. And this is a year-long process because it's a very challenging thing. Even we jump to inferencing and conclusions before, slowing down to make an observation. So that is something that I would do, periodically throughout the year or with the things that they're observing. How could you kind of slow down and do some see-think with them? Okay. Any questions? Like 2 questions, Janet, because then I'm going to work on making conclusions.
I think we're good. If anybody has pressing questions, jot them in there at the bottom, but we'll let Nicole continue right now.
Okay, so making conclusions is something, again, that we can bridge and review as well. So define what a conclusion is, or how you introduce it whole class, and use models or pictures to represent their thinking. Okay, so a conclusion is a statement, a claim that answers the question that draws support from data. Okay, so I'm going to say that in grades 1 to 3 because evidence isn't really used until grade 4. Okay, so how would you do this with the whole class? Well, I did this with one of the teachers I worked with in living systems. She was working on what's living or non-living, and she brought her dog Boogie, and they've been really working on it. So they made a claim. I know Boogie is living because he needs air. Well, how do we know that? What was that I could see that he was breathing because I saw his chest moving up and down. So it's getting students to describe the things that they observe to support the answer to the question. And of course, thinking routines also have questions that spark curiosity. So we have some examples here as well. Another area that helps work with this is learning summary tables, and I've used these in my classroom as well. So what they are is prior knowledge is clue stands for know, what have we learned? evidence or data, I think of data more or less, wonderings and the scientific words. I liked adding the words to it. So before they did a small scale investigation, they would come up with some of their ideas. So this is an example for light in grade 2. And then the teacher would record what, think, pair, share, record what the class said they learned, but they had to support that, just like the claim support part, right? The data, what do you see? What did you observe? And then any questions that they had, and then any kind of words connected or terms, scientific terminology that is connected to that, because it's good for all learners. So another area in science research is use of models, which, like in math, a model is a picture form, and using symbols to show or demonstrate movement or relationship between. So for example, this is the playground slide bump in kindergarten. They're going down a slide and the push and pulls. So there's some cards here that the teacher had provided. Some of the kids are writing it. Think of differentiation as you move up the grades. This is a great way to get students who may be challenged to write or speak, to be able to show in a different way. This is like the water cycle. Where does water from a puddle go? So they have the arrows and a little bit of a picture that they can work from. Okay, so this is an example of using pictures with sound waves in grade 2. They can add writing to it. That was answering the question, why did the glass shatter? The singer was singing into it, and that was their investigation. So they didn't know about pitch or anything. That's how they learned about it. And at the end, they shared out what their understanding was through that way. So again, you want to think about reaching all learners through multimodal representation in any aspect of what they're learning. So they can draw pictures, and it doesn't matter at what grade. Modeling or drawing pictures in science is actually a great way of communicating their understanding. They can write paragraphs or use technology to record it with any form of videos that I've kind of listed up here. So again, this is a long year process, right? Especially for grade 1, but thinking the gradual release of responsibility. I think, not I do, I'm not going to write a conclusion and you watch me write it. I'm going to do a think aloud. We think together. So there could be pair shares or hand up, stand up, and you're circulating so you can kind of get a pulse on what your class is, how they're developing. You think together in partners when I feel you're ready, and then you think by yourself. These are all kind of great strategies. So I do want to highlight, I know Chris highlighted some resources, but I'm actually going to go through some of the resources that you can access to support different learning outcomes and the organizing idea. So I know she talked about the little I. You click the I when you go on New Learn Alberta. And beside the cusp is an area for resources. So in K-3, there are these Pearson literacy ebooks. These ebooks can be shared with students via a link, or you can put it on the board and use that as some supplemental resource. Grade 3, Alberta Education has aligned and vetted and authorized the resources for gizmos. And so grade 3, it's more grade 3 and up. So there are, I think, in energy, living systems, and energy, I said energy, right? Living systems and earth systems. There are some gizmos for, those are investigations, they're simulations. Those are a form of an investigation. They're good, and I would use them after you've gone through a lot of hands-on and a lot of like building up that understanding before getting into a gizmo. The gizmos do come with student handouts that are modifiable, which I like, because although there are vetted and authorized, which are for alignment, some of the handouts they couldn't change it. So you have to kind of look at them and make sure that they align with your grade level science method things, and they have an answer key for it and a vocabulary sheet. So I just put in an example here. Those are examples of resources that are accessible to you. Okay, in a moment, This is the handout that you're going to receive. And in the handout, you're going to get the slides from today. You're going to get a lesson plans to introduce the scientific methods for about the first week, which zero in on observations and getting students really used to making an observation. And then you have grade specific look for. So I have one skill, so most of them connected to observation, except for grade 1, you get a little extra with prediction. And then a graphic organizer, which is like an investigation template for your grade level. And you guys were asking for the investigation cycle. So I'm going to drop that in each grade level as well. So what'll happen is these, and Jen, just hang tight. You're going to get this PDF, and linked are each grade level, and they're just your view only. So please make a copy to add to your Google Drive. They're in Google, and then you'll be able to get access to it. Before she drops that in, I do want to mention that I'm working really diligently on bringing it together series for each grade. So what that is how to teach and assess, bringing together, integrating. For example, I'm going to start in September with matter and scientific methods. And it's a sequence of lessons, because I've been hearing that, how do we put this together? So, and I've done after school sessions where you're tired and things. So it'll be a walkthrough kind of, and you will get resources that you can just like use in your classroom, not an entire unit or anything, but just kind of how to put it together and some look fors for that. So Janet, if you wouldn't mind dropping in the chat the handout for everyone, that'd be awesome. Thank you so much. So some of the key takeaways for today that I hope that you walk away with is an understanding that science uses methods of investigations to build knowledge and understanding of the natural world. Each grade learning outcome unwraps a deeper layer or focus on an aspect of the investigation cycle. There are criteria to develop skills and assess to help prepare students as they move on to the next grade.
Nicole, I just want to just butt in quickly and just let you know there's so much appreciation for what you're sharing today expressed in the chat. I won't read it all out. You can go take a look later, but I think you have given people such so much more peace of mind and practical skills and strategies. Like it's just lots of info coming up. Anyway, back to you.
Oh, thanks, Janet, and thank you guys. You know what? I just want to help as best as I can. But I'm going to open up on the mic. I'm going to hang back, and for a while, if you have any burning questions that weren't answered in the chat, or I kind of had to move a little bit, so I'm here to hang out for a while and answer any questions that you might have. And I'm just going to also put up my email address or follow me on Twitter. If you want to reach out or you have any questions, I'm more than willing to help you over the summer or anything. So, yeah.
You can tell that for Nicole, it is such a passion. And when she works so much on this work, and it is a labor of love for her, and she is happy and willing to share her work with us, and it's just, we're so lucky to have you here, Nicole, to be able to provide this support. And I'm looking forward to watching the recording again, honestly, today, so that when I put my final touches on tomorrow's, that I can integrate back in and hopefully use some of your templates as well, just to kind of help to align things. So look, thank you so much from everybody and from me too.
Oh, thanks, Janet. And I hope everyone has ability. I'm going to be helping Janet tomorrow, doing the same thing that she was so helpful for today and making it go smoothly with moderation. So I hope that, you know, especially I know the whole computer science question, and she's a wealth of knowledge. So to see you guys tomorrow as well and work with you tomorrow. But I'm going to hang back. So you can open up your mic. You can pop questions in the chat, whatever works for you.
Oh, you're going to drop in your email address into the chat, please. And yes, the tomorrow session, we'll put the recording, make sure you sign up for it. And then I think the recording comes automatically, but it will be shared as well. Can we share these resources freely with other colleagues?
Yes, that's a great question. Edmonton Regional Learning Consortium is Creative Commons licensing. So everything that's created is shared. You just please don't sell it on Teachers for Teachers. That's the only thing. You can share freely, you can modify, you can adapt to your context as you need. And so go ahead, yeah.
What's the easiest way to make a copy of it all? I always
Uh,
look for a
might-
right click and make a copy is sort of.
Yeah. Or you might have to it might have to be individually. I'm not 100% sure. So
If you have a
The-
folder in Google Drive, I wonder if you can just like export it with Google Takeout and if it'll give you the whole thing. That's another conversation. Takeout.google.com.
yeah, see, I'm glad Janet's here. She's going to give you guys, if you have those kinds of
Tech
questions.
geek perspective, yeah.
Yes, there is a recording. Okay, you answered that. Okay. Thank you, Janet, for sharing. Any questions, or you feel free. We're finished our session. And if you have any questions, just feel free to
Hang out.
yeah, hang out and open up your mic, ask any questions.
Thanks so much for coming, everybody. It's great.
Enjoy
You
your
have
the
such
rest of your
interest.
yes, and I really think that's going to help your students. You're going to feel less stressed, and you're here to learn for your students. So that's wonderful. No questions. Okay, I feel like we clipped along at a pace. Threads. I don't know what thread says.
I just find it so interesting. I'm having trouble with my chat right here. I find it so interesting how we can now get together across the province so easily, and then everybody can tap into everybody's little bit of wisdom. Like we had such wisdom in the room, and they were helping each other, and then your wisdom supporting us in the entire topic. And it's like nobody's got all the answers of everything, but to put the group together, it's pretty amazing.
Yeah, we can kind of help build on that for sure.
Somebody's wondering about getting yesterday's video, and they logged in late. Is yesterday's video? I expect that it'll be sent out by the ERLC staff, right?
On our email, will we receive the whole? Yes, CJ. Yes, you will receive like a recording is going to be sent out, and all the handouts are going to go with it again. Yeah. Yeah, the Jamboard didn't work. Yeah, I was worried about that.
Yeah, I'm hoping to use Lumio for a bunch of stuff tomorrow, and so I'm gonna have to think about that, because it's when we have so much content to cover, and how and yet we want that engagement.
Hi, Erica. Yeah, the recordings will get sent out for everyone who signed up, and anybody who came or couldn't come, you'll get the recording. Yeah, I'm going to see that. I'm really interested in seeing Lumio and learning about that, so that I can maybe use that as something, because the Jamboard was too many people have it.
But like I said, like me being me, I'll probably still use it, but it's so helpful to have the chat right in Zoom as well, right? Because that can be the plan B, and boom, straight to the chat. The speaker's email address, please, again, Nicole.
Oh, sorry, that should say arpdc.ca. Yeah.
ARPDC.
I'm gonna start.